Hello, welcome to the judges introduction video for the 2026 Mate Florida Regional Competition. First of all, thank you for volunteering. The competition is one of my favorite experiences every year, and I hope you also have a great time while at the competition. I'm Seth Backler. I am Regional Coordinator with Colby Gemmel and working alongside the rest of the team at FIO and USF. So the Florida Institute of Oceanography has been a wonderful partner, really taking ownership of the regional, and I'm really happy to have their support. So we're looking forward to another good year with them, and you probably already hopefully already heard that we will not be competing at the USF St. Pete campus where FIO is normally based, but instead at the USF Tampa campus, because our regular pool has a leak. But thankfully we were able to relocate over to USF Tampa. I have a lot to go over. I know this video is very long, but I'll provide chapters listed below so you can jump to whatever is relevant for you. So for example, if you want to watch this introduction, just the Scout or Ranger mission fly through, and then just the demo or marketing or presentation, whichever is relevant for what you're doing, then you'll have everything you need. And also everything that I share today will be sharing this video is up on the Mate website. So if you just Google Mate ROV and go to compete, and in the compete section, there's classes and Scout and Ranger. So if you go to on the Mate website here, if you up at the top, it says compete, and go to classes and go to Scout or Ranger, you can find everything that I'm about to share today. All right. So the winning Ranger team earns an invitation to the international competitions, which is at St. John's, Newfoundland this year. Pretty exciting to be going back to Canada. And there they will represent the state of Florida. If we have a great second place team, Mate may extend an invitation to them as well, depending on how they perform. But we do not have enough teams this year to guarantee sending a second team. The theme this year is pushing performance, science, technology, and discovery in harsh environments. So task one involves collecting coral samples, 3D modeling a coral garden ridge, and maintaining position over a coral garden to film a section of the garden. Task two involves determining the number of certain crab species in an area, tracking floating icebergs and their likelihood to collide with oil platforms in the area, recovering a lobster pot, and recovering a buoy anchor, and replacing a eDNA sensor at a subsea observatory. Task three involves installing a micropile to secure a windmill to the sea floor and connecting that turbine to an oil platform to power it. So using wind power to power an oil platform. Task four is to deploy a vertical profile float that can take sensor readings at different depths along a water column. So float, a tube that the students will build themselves that goes up and down in the water column to it could take temperature readings and depth readings as it travels. All right, starting with the schedule of the day and some logistics. First is parking. There is paid parking, and unfortunately there's no free parking at USF Tampa. Let me pull up the map I meant to have ready. Here we go. So the competition will be in two buildings primarily. Here we go. So it's in the rec building. This is where the actual swimming pool is, and the education building, EDU. So you can see these two are quite close together. I think I measured them 700 feet apart, something like that, with good sidewalk access between them. You can park in this 7B or this 6. Really, you can park in any of the dark green parking lots, and there you still have to pay for, and you can pay through Park Mobile. But any of these dark green lots are okay. But this number 6 lot and this number 7B are the closest to where we'll be. We're going to do sign in for the day at the rec center. And I think we're doing kickoff in the rec center as well. Let's see. There are restaurants in the Marshall Student Center available, but we will also have coffee. We'll have snacks, and we'll have lunch available for volunteers. If you arrive early and no one is in the rec center for check-in, there probably will be someone, but if not, we'll probably be in the judges room in EDU 254. So EDU 254 is sort of volunteers or judges break room. That's where we'll have snacks and drinks available throughout the day. And we'll also have coffee there to start the day, just available for judges and volunteers as needed. Please be mindful of dehydration and just general exhaustion throughout the day. Divers especially is one they often don't realize they're getting worn out because they're in the water, but those are often some of the quickest to get worn out. Take a break if you need one, but this year should be easier because this year everyone is out of the sun, so the swimming pool is an indoor pool. I'm sure it'll still be warm in the pool area, but very happy to be out of the sun this year, so should have an easier time with that. So as everyone arrives and you get checked in, feel free to go to your areas. You're all judges are welcome to join kickoff and opening ceremonies. They're very quick. But generally, when everyone's getting settled in, it tends to happen very quickly. So, check in, just let us know that you're here. There's a quick sign-in sheet for volunteers, and then you'll go to, if you're presentation or marketing judge, you'll head over to the education building, this EDU building, and then this building here. And then if you're in the pool and mission demonstrations, you'll be over in the rec, in the pool area. So go ahead and head over to your areas, find your stations. There should be folders with all the paperwork you need. Open them up, look through them, see what you got. If anything doesn't make sense, flag us down. Colby will be the pool master. I will be the score master. So especially for the presentation team members and our marketing display team members, I'll be answering questions for you. And then for anything poolside, Colby will be answering questions for you. All right, so getting into the mission, we're going to go ahead and fly through the missions here. So starting with Scout, which is generally middle school, a couple high school. Task 1, Kaleidoscope of Coral. So kicking off with Task 1 is collect 2 basket stars and return them to the surface, to the side of the pool. 5 points for each that are collected. Next is collecting 2 coral species and return them to the surface. That's modeled by these little pipe cleaner doodads. So again, 5 points each. Next is to fly a transect over the coral garden. So they should be able to fly and stay within the box defined by these ends here. So the ROV should be able to stay in the box. You do have to use your judgment here. It's really so long as any part of the ROV is over this center line, then that is a valid flight of the transect. If they leave the line at any time, they can restart the transect by going back to one end and going to the other side. The purpose of the transect is to get a consistent one long stitched together image of that area. It has a lot of scientific purposes. For example, you could see the density of some sort of animal or plant life in that area if you have a stitched together image of a large area. Okay, task 2. We start by recovering 2 crabs to the surface side of the pool. By the way, the teams are allowed to place these in a basket if they bring a basket and the RV can bring up the basket. They can get creative with how they bring all these things to the top. They cannot like attach a rope to it and use human power to pull up the rope. But as long as the ROV is using its thrusters to bring the item to the surface, they can be creative with how they actually do that. Next is iceberg tracking. So this is making sure that icebergs aren't going to slam into an oil platform. They start by tracking where the iceberg is heading. They survey the iceberg at 2 locations. So they have this object, which is available poolside at the beginning of the mission. The ROV then attaches this item to that. These are Velcro. There are 2 survey points on the oil platform, so they connect one to one point, one to the other point. Once they've attached those items, the judge will give them this sheet, which is the iceberg information. So essentially, they've attached this survey tool. The survey tool reports back and says, this is the direction that the iceberg is heading. It's heading at this speed, etc. Using that data, they then will calculate what is the threat level to the oil platforms in the area. So you give them this piece of paper, they should be prepared to interpret that piece of paper to say this is the direction that the iceberg is heading, and it's going to be within this many miles of these oil platforms. Therefore, these oil platforms are green, yellow, red. This can be done on their laptop. This can be done by hand. This can be done on an iPad. However they choose to do it. This is, they just have to tell you what is the threat level. And we'll have a cheat sheet for you that says the correct answer. By the way, the data and the answer will change for each station, but you'll have a cheat sheet for your station. Next is testing whale-safe fishing gear. So we start by, this is a lobster pot that is whale-safe. So we start by turning this handle, which releases it's an acoustic release of a retrieval buoy. So they turn that handle, and that floats that to the surface. So it's allows it to be recovered. And then next is service the subsea observatory. So there's a subsea observatory nearby, and it has a eDNA sensor. The team needs to collect that eDNA sensor, bring it to the surface. Once it's on the surface, you will give them the results from that sensor. So it's a piece of paper that says these are the species that were found at a certain frequency. So you saw this crab this many times over while the sensor was deployed. They then use that to say, this is the frequency that we saw. This is the percent frequency that we saw each species. And you'll have, again, a cheat sheet of what the correct answer should look like. Next, there will be a new eDNA sensor that they'll deploy back to the same location that they picked up the old one. And once the new eDNA sensor is placed, they'll have to connect it. So they pull out this connector and plug it into here. And that's task 2. Moving on to task 3. So starting out, I think I scrolled too far. There we go. So task 3 is powering an oil platform from a wind turbine. So you can imagine that a wind turbine was just installed. This is the power plug from the wind turbine. The scouts will pick up that plug they will carry it through a waypoint. So through a waypoint is defined as the cable has to end up between at least two segments of this waypoint. So if the cable wrapped around just this far end piece, that wouldn't be enough. It has to go through the center in any direction. It has to kind of cut through the center of a waypoint. And then get plugged in. There's Velcro on the end of this to help keep it in. Next is task 4. So this is creating a vertical profile float. They have to bring design documentation that shows what they designed. Either it can be use a buoyancy engine or it can not use a buoyancy engine. So a buoyancy engine means that it's somehow the float uses a change in buoyancy to make itself rise or fall. This usually, especially for Scout, will look something like a moving syringe inside the vehicle that is half air, half water, and by either compressing the air in the syringe or by having a tube all the way to the surface and moving the syringe in and out on the opposite side, they can put more air or less air in that syringe, and by doing that, make the float go up and down. Alternatively, they could just use a motor with a propeller, as you see here on the left. So there's lots of ways that the teams can solve this problem, but the teams do get additional points if they use a buoyancy engine. So something that changes the buoyancy characteristics of the float to make it go up and down as opposed to a propeller. So it must get deployed to the designated area. So it has to get past the green line. And then it must complete 2 vertical profiles. So that means all the way down, all the way up, all the way down, all the way up. That's 2 complete profiles. Now those profiles can be done autonomously or manually. Autonomously means it goes all the way down and then it makes its own decision to go all the way back up. So there can't be any flip of a switch or any button press by the team member that tells it to go up or tells it to go down. So it's just on its own. It knows go down, stop, go up, stop, go down, stop, go up, stop. That's worth a certain number of points. If it's done manually, that's worth less points. I know at least one Scout is attempting buoyancy engine autonomous, so we'll see how it goes. But it doesn't matter how long it stays at the bottom. It doesn't matter how slow or fast it is going up and down. Just has to do the whole 2 vertical profiles. Once they complete the vertical profiles, you will give them another set of data as if they had collected temperature and depth data. They will then use that provided data to create a chart that shows the temperature versus the depth. This can be done by computer or by hand. If it's done by computer, it's worth a little bit more money or a little bit more points. It really just has to be, it can just be an Excel spreadsheet that's been pre-prepared for them to fill out. It doesn't have to be anything terribly sophisticated. But they may choose to do it by hand, and that's fine. And that should be the Scout mission. All right. Now getting into Ranger. If you sat through Scout with me, you'll see that Ranger is quite similar. Just scrolling up here. All right. So getting into Ranger, we have task 1. And task 1 starts with collecting species from a coral garden. So that looks like this. They have to collect 2 of these. And then next they have to collect 2 coral species like this. If they pick it up from anywhere except, or if they pick it up from this main PVC end cap, which is the base of the coral, they get 10 points each. If they pick it up from anywhere else, that's 5 points each. So if they pick it up from the other parts of the PVC, if they pick it up from the pipe cleaners, that's 5 points. They get extra points for picking up from the base. If it touches another part of the ROV on the way up, but they're still holding it by the base, that's fine. Like if the pipe cleaners end up like touching the ROV, that's not a problem. So they have to get 2 of those. I mentioned this in the scout video, but if the team chooses to use a basket or something like that to transport them up to the surface, that's totally fine. They can't use human power. Like they can't have a rope with a hook on it and attach the hook and use a human to pull it up. The ROV has to use its power to bring everything to the surface. But they can use a basket. They can have multiple arms. They can, however they creatively want to solve the problem. Next is modeling a coral garden ridge. This is using, this can be done multiple ways. This can be measurements done very manually with a tape measure. This could be a full, they use, and then they draw it out by hand, or they can use tape measure or something like that and manually create it in CAD on a laptop while they're there. Or the most sophisticated version is fly around the coral garden ridge and take images or video all the way around, and then have a program already built and ready to go to use for photogrammetry to autonomously create a 3D model of the coral garden. So that's what this video is demonstrating here, is a fully autonomous system that they fly around the garden, the coral garden, and creates a model for you right away. A couple teams, I'm sure, will actually do this. And the way that you can check that the model has all parts is that all 8 targets around are showing. So these are little squares on the coral garden, and the point of the squares is to make sure it sees all sides. That's how we're defining that it sees all sides. Once that is created, any tool like this can only create the 3D model, but it will not know the length. It won't understand the scale. So they will still have to somehow scale it. So measure any part of it they want. Or no, it does actually say in the rules. So they have to measure the total length of the coral garden and then tell it to you within 5 centimeters. Again, we'll tell you in the cheat sheet what it is. And then they need to scale the model that they've created to that. Once that's done, use the scaled measurement to estimate the height of the coral garden. This is just showing, again, if they, instead of doing the fully autonomous system, were to manually do it in CAD, they could measure the length, measure the height, and do it that way. Okay, next is flying a transect. So this is in a couple teams may be confused by this. We sent out a note to the teams clarifying. We will be using the World Championship version of this challenge, not the standard regional championship version of this challenge. The regional championship version is flying a transect. So flying straight along a path. You're not allowed to deviate from it left or right. So you cannot go outside. You have to see both blue lines all the way from end to end. In the World Championship version, you have to keep a blue box in focus. But if you fly further away, you would see, let me see actually if they show it failing. No, they're not. They don't show the failure. If you were to zoom out, I think it's yellow. But there's a box that's bigger than the blue box that if you were to fly away, if you were to go up as the ROV, and you would see see the yellow box around it, and that's a failure. So you have to be close enough to this blue box that you only see the blue box and have to hold there in place for 30 seconds. That is the challenge that we're doing. We're not doing the transect. In the World Championship, this is even harder because they'll be in a pool with a current, so there'll be actual current pushing against them, trying to move them. We don't have a current, but still in the swimming pool, it's still going to be a big challenge, and I'm curious how much teams struggle with this one. All right, so they just have to maintain in place for 30 seconds and can't leave the blue box at any time, and they can't zoom out, too much at any time. All right, moving on. Next is determining the number of an invasive species of crab. So they can do it manually for 5 points or autonomously for 15 points. So you'd expect to see a system that actually highlights and says, these are this crab species. And it's not just circling all the crabs, it's ones that match that species based on the image provided. Then they are expected to upload the data to an invasive species form. We've printed out QR codes that should be on the desk when the teams get there. So the teams would just scan the QR code. They can do it with their phone, they can do it with a laptop. And they are actually uploading this number to a database. So you should see them do that, and they should show you that they've done it. Next is iceberg tracking. So seeing if any of these icebergs are going to be a risk to any oil platforms in the area. So first, they survey the iceberg at 5 points around the perimeter. So you should be able to see 1, 2, 3, 4, 5. And you'll see one of the numbers will be lower down than the other numbers. So get all 5 points. Then they need to measure the keel depth. So how deep into the water does the iceberg go? And whatever they report to you needs to be within 10 centimeters of the true depth. Again, that'll be on your cheat sheet. Once that's done, you'll give them iceberg information, which will tell them now that they've collected all this data, what's the actual direction of the iceberg, where is it, and what's the depth that the iceberg is. And based on that, they should be able to, either on a laptop or a piece of paper, most ranger teams I would expect to have a laptop ready to go with all this information pre-uploaded, and then they can just enter in the info that you give them. And it'll say, this iceberg is traveling towards these oil platforms. It's going to be within this many miles of these oil platforms. Therefore, this is a red risk zone, a yellow risk zone. And if the platform is in a particularly shallow area and the iceberg is particularly deep, even though it would get close, the iceberg might be so deep that it would run aground anyways, so it doesn't matter. So there's a couple factors that the rangers they should know ahead of time because it's all in the rule book. As a judge, you'll have a cheat sheet that says these are the red ones, these are the yellow ones, these are the green ones. Next is There we go. Next is testing whale-safe fishing gear. So this starts by turning this handle here, which releases a recovery buoy. Then they recover the lobster pot off the side of the pool. So this is going to be very heavy. This is supposed to be a challenge for the ROVs. Bring it to the side of the pool like that. Next is, oh, that was a retrieval buoy. So next is, this is the recovering the lobster pot. Sorry, the last was retrieving the buoy. So you'll attach the buoy. Oh no, I had it right. That was the lobster pot. This is recovering the buoy anchor. So you'll attach a carabiner to this clip, bring it back to the surface. So that it can be recovered later. The teams don't need to actually pull up the buoy anchor once they have it up there. They just need to return the line to the surface. The next task is servicing a subsea observatory. So first, there's an eDNA sensor that has been deployed here. The teams will go out and recover that. Once that is on the pool side, the judge will give them this data sheet, which will be in your folder at the station. And for each station, these will be different sheets. But this will say, the eDNA sensor saw this data. Based on that, the students should be able to update a percent frequency for all the species that were in the area and show you that. Then they'll deploy a new eDNA sensor and plug that into the observatory. Both of the plugs have to go into these PVC, so it can't just be one. And then finally for task 2, they have to remove biofouling from the subsea observatory camera. So that is grabbing this, there's a PVC T here, and they're going to spin it. Is it 3 times? Yeah, 3 times. So you'll see the blue and yellow kind of spinning, and that's to help you keep track of how many times it's spinning around. Next is task 3. So installing a micropile on the seafloor to secure a wind turbine. So first, the teams are deploying this red ring, which represents a bubble curtain. So if this were real world, the idea here is a curtain of bubbles of air pumped in will create a wall of air bubbles, which will substantially reduce the noise impact of this construction work. So trying to reduce the impact on the wildlife in the area. So deploying this ring, placing the micropile into the designated location. So one team member is actually going to hold this this rod with that actually is used to deploy the micropile. This is all provided by us, so this will be on the side of the pool at the start of the mission. The team member is holding the rod out, and the ROV pilot is actually guiding them, saying, to your right, to your left, forward, back. It'll be interesting to see if they can all keep right and left, correct when giving their directions. But the team member will put the micropile over, use this string to lower it down. Once it's installed, the ROV pilot will pull the pin, securing the micropile. Next, they'll remove this cap from this power port. So this will be, this was all for installing a wind farm, and now they're going to use the windmill to power a oil platform. So they're releasing the power port on the oil platform, bring that to the surface. Then they're getting the power plug from the wind farm, They have to run the cable through a waypoint and then put the plug into the port. And there's Velcro on the end of there to hold it on. All right, and then finally task 4. So task 4 is about designing a vertical profiling float. So the team must take the float to the designated area. The float must communicate with the station prior to descending, so you should see data showing up on their laptop or some other screen that shows data being received. Then the float must complete 2 vertical profiles. So each vertical profile has the float going to 2.5 meters and holding for 30 seconds, then going to 40 centimeters, holding for 30 seconds, and then repeating, going down to 2.5 meters and back up to 40 centimeters. This is very challenging to make a float go to a depth and stop and stay there. There's a lot of physics that goes into balancing that. As the float will descend, it will naturally want to accelerate faster and sink all the way to the bottom. They're allowed to go to the bottom. They're allowed to tap the bottom. They can go past 2.5 meters, but they get the points for eventually ending up at 2.5 and then staying there. So it is going to be a very big challenge, and I'm very excited to see how many teams actually complete it. The teams do get a penalty for breaching the surface of the water. So while they can go all the way down and hit the bottom of the pool in their profiles, they do get a penalty for breaching the surface. The reason for this is, in theory, this is happening under an ice sheet. And so if the float were to go full speed up into the surface, it would actually collide into an ice sheet and potentially be non-recoverable at that point. Once the 2 profiles have been complete, it is then expected to breach the surface. It is expected to transmit the data to the mission station wirelessly. Then it is expected to profile the depth over time. Now, if they don't if they don't have a working profiler or a working float, or if it doesn't do data, there is an alternative chart where you can give them the data and they can create the depth over time separately. So if they don't have any of these systems working, they can get some points for doing just this part of the task using a set of data that judges will provide. So that's it. That's the scout mission. That's the ranger mission. Yeah, now let's go into all the different segments of judging. All right, the first judging section that I will focus on is pool demonstration judging. For the pool demonstrations, each team will have 2 attempts to complete the mission. The mission is separated into 4 tasks, but they are all presented simultaneously. So the teams can do the 4 tasks in different order. Most tasks can be done in any order within the task as well, but a few must be done in order. So for example, you can't plug power into a port if you haven't opened the door to that port first. So there's a couple of things that logically need to be done in order, but the vast majority can be done in any order. Only the highest total score of the 2 attempts will be used as the determination for their final place in the competition. Depending on the number of volunteers, we usually prefer to have 2 judges at each station. We should be able to do that, as well as a couple additional roaming judges who can be available for restroom breaks. Right now, we do think we'll have 1 or 2, so we'll be able to make it. If you need to step away for a moment, we'll have that option. The schedule is pretty tight this year, especially on the scout side. The schedule will be pretty tight this year, so we have to try and stay on schedule. There will also be a couple divers in the pool who will be resetting the mission area between each attempt. Teams may also request diver assistance with a 5-point penalty to get untangled or recover the ROV to poolside during their attempt. The clock does not stop during diver assistance. Sorry, my dog wants to come inside. If the mission attempt is interrupted for any reason outside the team's control, such as a bad mate fuse, or we lose 110 volt electrical power at the station. So if there's some reason that is not caused by the team, that they're unable to continue, immediately pause the clock until the team may resume. If you're unsure whether or not the issue is caused by the team, or if you should pause the clock, that probably means to just go ahead and pause the clock. Just make sure that the team also stops what they're doing while the clock is paused, and then whatever the problem is resolved, you can resume the clock. It's unusual that this happens, but it is possible that maybe a fuse blows or something, and it turns out that we've put in the wrong fuse or something like that. But generally, once the clock for the challenge starts, it doesn't stop until the challenge is over. When students approach, when students walk up for their scheduled time, they will be anxious. Make sure you welcome them. Please be friendly and polite, and make sure that they know that you're not there to try and make things hard on them. You're there to give them this opportunity for them to perform. When they first approach, make sure to tell them, don't start setting up. You can put your stuff down on the table, but that's fine. But don't start setting up. Ask for their safety pass. That'll be a little printed, laminated card that says, Ranger 2 safety pass, whatever their team name is, whatever their team number is. So make sure they show you their safety pass. That means they have passed safety inspection and they're able to compete in the water. Tell them how much time they'll have. So for scout teams, they're going to have 3 minutes set up, 10 minutes of mission time, 2 minutes to pack everything up at the end. For Ranger, they'll have 5 minutes set up, 15 minutes of mission time, 5 minutes to pack everything up at the end. Tell them that if they run out of time during their setup, their mission time will start immediately, even if they're still setting things up. Ask them if they have any questions. Try your best to answer any questions, and if needed, reach out to the pool master, who is Colby this year. There's also quite a few long-time competition volunteers on the deck, like Woody Lee and Billy Freed, and there's a bunch of I'm sure Eric will be around the deck. There's a bunch of long-time volunteers who can also help answer questions. If the team is good to go, tell them that their setup time starts now, and go ahead and start the timer. You can use your phone or a stopwatch throughout the day, but just any timer is fine. So again, for Scout, they have 3 minutes to set up. For Ranger, they have 5 minutes to set up. When they're done setting up, ask them to confirm that they are ready. If they say they are ready, say then, all right, your mission timer starts now. Again, 10 minutes for Scout, 15 minutes for Ranger. They may ask you at any time how many minutes are left, and you can answer. Also, I like to give a 1 minute warning when they're about to run out of time, but I wouldn't distract them more than that unless they ask for it. If the team says ahead of time, hey, can you give me a 10-minute warning, 5-minute warning, that's fine. But I wouldn't do that unless they ask for it, because you may just stress them out and, if it's not wanted. In the highly unlikely event that they complete all tasks, make sure to stop the timer. They do get a time bonus if they get a perfect score So you'll want to make sure you capture that. It's not going to happen. It hasn't happened in many, many years. But if a team gets a perfect score, you want to be aware of what their remaining time is. Scout class teams are allowed to look into the pool freely during the challenge. So if the pilot is looking into the water while driving around, or asking his friend, what direction he should go, or the person who's poolside says, go to the left, that is okay for Scout. However, for Ranger class, the pilot may not look into the water at any time. So the pilot ideally is at a table with their back to the water. They may only look at the TV monitors, at the computer screens, and use the cameras on the vehicle for guidance. Team members can't switch back and forth between poolside and piloting, so whoever's sitting piloting can't go be poolside, and vice versa. And the team members that are poolside cannot tell anything to the pilot about what is happening below the surface. So the people who are poolside, who are managing the tether or taking things on and off the ROV throughout the challenge, they can't turn around to the pilot and say, go left, go right, go right. It's right in front of you. They can't talk about anything that's happening in the water. They can say stuff that they could see out of the water. So they can say, you're out of tether, or the ROV is at the surface, or you're about to run out of tether. But the idea is, if they were 500 feet down in the ocean, the people leaning over the side of their boat wouldn't be able to help them. So they can't say anything back to their pilot about what's happening in the water. Give them one warning. They get one free warning. And then if they continue to do that, they continue to have illegal communication. Start issuing penalties. Just let them know, make sure you're clear that that is a penalty, a penalty for illegal communication. That is another penalty for illegal communication. I would say if they try to start talking with you about it or arguing about it, say we'll talk about it at the end of the run, because you want them to stay focused. You can start penalizing, just put tally marks on illegal communication. Now back to both Ranger and Scout. So poolside, no team member may reach into the water beyond their elbows while deploying and retrieving the ROV. So we don't want their whole first front half of their body in the water, just up to their elbows. The team may place the ROV in the water during their setup time, but it must be held by a team member at all times. So they may want to put it in the water, make sure it's not sinking, something like that. But they can't go drive around. They can't go too far away from the pool side. It has to be held by a team member. Team members poolside may not intentionally control the ROV by tugging on its tether. So if they see that they want the ROV to go just to the right, it can be tempting for them to just yank the tether a little to the left to turn the ROV to the right, to try and tell the pilot hey, you should be going to the right. Or if they are coming back to the surface with something heavy to want to pull on the tether to bring it up, that's not allowed. If you believe you see them doing that, give them a warning. Say, hey, don't. I'm trying to think what we actually call it. No tether pulling. And if they continue to do it again, say that's a penalty for pulling the tether. You will see them pull it up because the tether manager should be putting more tether out or pulling it up to match what the vehicle is doing, so there's not excess tether in the water. But they shouldn't be actually moving the vehicle with the tether, or at least not intentionally doing it. As the teams compete, one judge usually keeps an eye on the camera screens while another looks in the pool. That's together they're able to keep track of what is and isn't being completed. But do whatever works for you. Each station has a pair of judges, and you all can talk about what works best for you. You'll have a score sheet and a clipboard. Fill it out as the team goes. Some runs will go very slow, and a few will go very, very fast. For the teams that do go very, very quickly, you can ask the team for clarification. Are you attempting this task now? What are you trying to do now? The teams will be happy to tell you what they're doing. Every year, teams complain about power issues. Teams say that the power supply is not acting the same as their power supply at home, and that's why they're having problems. We use the same exact power supplies as the international competition, and every team must use the provided power supply. Double check that the back of the power supply is set to the 110 volt option. There's a 220 volt option. So just make sure that the little switch does say 110 volt. But generally, it's a common excuse for when things aren't going well. If teams have any other concerns or complaints, try your best not to stop the clock. But if you feel it's necessary to escalate to the pool master in the moment, please do so. We'd rather make sure the issue is resolved. And then as soon as their run is over, quickly announce that their put away time starts now. So when they hit the 15-minute run, and that timer goes off, say, all right, that's the end of your 15 minutes. Your put away time starts right now. While they're putting things away, that's when both the two judges at each station, you can confer with the other, with your co-judge and say, I think I got this, did they do this? And sort of get all that, tallied up. And, so you get it all tallied up and sum up the score. There are penalties for teams that are really late cleaning up and leaving the area. So if it takes them 10 minutes to put everything away and get and walk away, then we'll penalize. But really, if they're 1 minute late, we're not trying to penalize them just because. Before they leave, you will tell them their final score. You'll tell them if they have any penalties. You'll explain the penalties. You will have the CEO sign the score sheet, and you will keep the score sheet after the CEO signs it. A volunteer will come around later to collect these score sheets throughout the day. Please try not to argue with the teams about the scores. Leave that to the pool master, Colby, or score master, myself. Also, just a request: do not create any penalties for a team because the team is being argumentative or not being professional. We have to stick with the rubric and only penalize for reasons listed in the score sheet. If you have other concerns about a team's behavior, feel welcome to talk with me or Colby, but the rubric, we have to make sure that we stick closely to the rubric. So we'll go ahead and walk through the rubric here. This is the Scout rubric. You'll see a lot of similarities, but I'll walk through them both real quick. Make sure you check here that the safety inspection card was presented. As you go through, you'll see collects the basket stars. So if they collect one of them, you'll circle 5. If they collect both of them, circle 10. Same with the coral species. Flying transect, 10. So then you would tally that up and put the score here. Smart Atlantic, so going on to recovering green crab. So it's the same idea as you go down. You circle, did they get, for this one, surveying the iceberg, it's 10 points each. So if they did both survey points, you'd circle 20. Trying to think, go down, use the location. So here's one where they determine the threat level to the 4 oil platforms. So if they get all 4 correct, you circle 15. If they only get 3 correct, you circle 10. If they only get 2 correct, you circle 5. If they get 0 or 1 correct, you circle 0. Going down. All of these are pretty straightforward. So yeah, here's a more complicated one. So this is the vertical profile float. So if they perform the task with a buoyancy engine, so that's any sort of device that changes the buoyancy characteristics. So you could think of like a balloon or a moving syringe or something that creates larger air pockets that would, or other gas that would cause it to become buoyant and move up, or vice versa to go back down. That's a buoyancy engine, as opposed to like a thruster or motor. That's not a buoyancy engine. There's also the autonomous versus manual So if they get extra points for doing it autonomously, so a system where that automatically sends the float down and then back up and then down and then back up, as opposed to manual where they're flipping a switch or some other mechanism to say, now go down, now go up, now go down, now go up. So for this one, profile 1, if it has a buoyancy engine operating autonomously, that's 15 points, so you circle 15. If they're buoyancy engine but operating manually, that's 10. Or if they're not a buoyancy engine but autonomous, that's 10. If they're using any other mechanism, that's 5. Okay. Here's where we get into penalties. So you'll just tally up the infractions as they go, and then each infraction is multiplied by 5. In most cases, you will have 0. You will certainly have a team or two that has some infractions, but the majority should be 0. Time bonus, sadly, never happens, but would be very exciting if it does. Okay, getting into Ranger. The Ranger score sheet has a bit more to it. First is inspection safety card. They should also present you with a JSEA, job site environmental analysis. You're not grading the JSEA, but there's be some effort. If it's a piece of paper that just says JSEA on it, that's not acceptable. But then getting into operational effectiveness. This one, don't have to be extremely strict about this one, but is there a sense of a chain of command? Is there a sense of clear roles and that are executed well, composure under pressure, supportive of each other? These sort of things are usually pretty obvious, I would say. You're not looking for something that's amazing, just are incredible, but you're looking for do they all have pre-assigned tasks? Do they know what they're doing? Is it, have they obviously rehearsed this before? Also, task plan well thought out. Do they have a task plan? Are they kind of talking through and say, what should we try and do next? A team should come with, we're going to try this, and this in this order. Alternate plans available, and all teams made aware of the plan. So if something goes wrong, are they able to adapt and they have plans to deal with that? Are they aware of timeline? Were they surprised when they ran out of time? Adjusting timeline to adapt the situation. So if they're running out of time, are they adjusting? ROV deployed by the end of the 5-minute period. This one's cut and dry. Did they meet the 5-minute setup period? ROV is under control of pilot and prepared to perform tasks. So pilot's able to control the ROV and actually do tasks. Next is bonus points for weight. So we will let you know the weight, or either we'll write it on a piece of paper, because we're going to weigh them as they come in. So we'll let you know what the weight is, and then you can fill this out appropriately. All right, going through just like we said for Scout. So, collecting 2 basket stars. So if they do 1, you circle 5. If they do both, you circle 10. Collecting coral species. This one is by the substrate. So as I showed in the demonstration, there's like a main body that's the PVC end cap. If they collect it by the PVC end cap, and they do both of them by only holding it by the end cap, that's 20 points. If they do 1 by the end cap and 1 by the pipe cleaners, that's 10 points for this one, 5 points for this one, so 15. So it could be a combination as they get both. And then this one, so for section 1.2, coral ridge modeling. So this is the model of the full coral ridge. You have to choose one of these 3 boxes. You see how it says or. So if they're using fully autonomous 3D model, so they flew around and took photos or video and uploaded that into a tool, that's what this section is. And so you would only score this section. Or if they measure and then make a CAD model manually, you would do this section. Or if they measure and draw it on paper, you do this section. Okay. Trying to think what else is. So yeah, I mean, going through the rest, it's hopefully pretty self-explanatory. I know there was one more. So float is another one that's pretty complex. So they get different points whether they use a buoyancy engine or a different mechanism, such as a propeller or motor-driven system. They also get different points for doing it. Let's see. Oh, I was about to say autonomous versus manual, but they're all autonomous in Ranger. So they get 5 points deducted if they break the service during the 2 vertical profiles. After the second vertical profile, after it maintains at 40 centimeters, it then does need to break the surface for recovery. But it shouldn't break the surface until it completes the 40 centimeters for 30 seconds. Now, if the team does not design and construct a float or the float does not communicate data, companies can instead choose to get 10 points by taking mate-provided data and using that to create a graph of depth over time. And then again, as mentioned before, if they have any of these penalties, you'll tally them up as you go and then add them up and multiply by 5. Then you'll fill all that out and then get the company CEO to sign or to initial at the bottom. So that is the product demo. And glad you all are inside this year, not out in the sun. I hope the weather in the pool area is comfortable, and hope it's a fun and on schedule time this year. Thank you. All right, next will be the marketing display. So for the marketing display, this is like a trade show. The idea is the team is selling their vehicle to the general public. They need to be able to communicate what the vehicle does, what it is as a product, and this is meant for non-engineering audience. This is meant for the general anyone who might be considering buying their vehicle as opposed to engineers that understand building the vehicle. We will have at least 2 judges for every poster. You may judge throughout the day, starting at after the marketing display judges briefing. So around 11 o'clock on, you'll be free to judge the posters on your time. But they take a fair bit of time to judge each one. It should take you about 20 minutes to go through each one. So once the briefing is done, make sure you do get started just so you aren't crunched for time at the end of the day. Parents and students are allowed in the poster room at any time, including while you are judging, but they may not present their poster in any way. So if they're lingering around the poster and you're trying to start judging their poster, feel free to say like, hey, actually, I need to focus on judging this. Would you mind stepping away? But it is normal for parents to come through and read the posters, especially of other teams, while you are in the room judging them. Some teams will add a lot of nice flourishes, such as 3D printed models or candies or business cards or things or tablecloths or things are in and around their poster. And if you believe these are deserving of discretionary points, you do have that option at the end of the rubric. But it's important that the rest of the rubric is graded on what's actually on the poster. So for example, if the actual poster doesn't have anything about the theme of the competition, and there's a whole section in here about theme, if they put a piece of paper in front of their poster, that is not adequate. score is based on what's on the poster, other than the discretionary if you choose to do that. So going through this rubric a bit. First, company name and section headers. This one is very straightforward. Do they have their company name? Do they have all the required headers? Is there literally the word abstract over a section? Is there the word company information, design rationale, theme, company evaluation, acknowledgments? Some of this parts of the rubric are not meant to be cute or flourish or anything like this. It should have those words above sections. It should include the location of the company. Is it Orlando, Florida, USA? And if it includes all of the criteria, then it's a 2. If it's missing anything, then it's a 1. If it's missing more than one of the criteria, it's a 0. Overall, is it visually appealing? Is it a logical progression, easy to follow? Is it similar fonts throughout? Obviously, not all of it needs to be one font, but is it is it somewhat consistent? Is it easy to read from 1.5 meters away? A common issue that comes up is overly fancy backgrounds that make the text hard to read. And at the end of the day, the text on the poster needs to be the most valuable part. Header font and section font consistent throughout. So again, just consistent fonts. Are all measurements in metric units? So this is an interesting one. Technically, not all measurements have to be in metric. So if there's a standard unit that is not metric, so 1/2 inch PVC, we don't want them to say, whatever 2 point, whatever centimeter. We don't want them to convert things that don't make sense to convert. So standards like 1/2 inch PVC is acceptable. Standards like, I'm trying to think of another one, 40 psi is so things that are commonly sold in a imperial unit is acceptable. However, everything else should be metric. So the size of their vehicle, it's 20 centimeter by 15 centimeter, whatever it is, or if it's 12 kilogram weight, any other unit other than a standard purchased, like 1/2 inch diameter PVC must be in metric. Is the poster bigger than 36 by 48? That's a penalty. It must be 36 by 48. If you're, we don't have to measure every single one, but if you have a feeling that one is looks significantly bigger than the others, let me know. We'll grab a tape measure and we'll double check it. Grammar and spelling, writes clearly, concisely, using correct grammar, spelling, syntax, sentence structure. It shouldn't have any errors. I was about to say like 1 or 2 spelling errors, but no, it should not have any errors. Photo captions. This is one that teams often do very poorly. Every image in the poster needs to have a caption or credit. I always smile when I see a team put somewhere that says "unless otherwise noted," photos taken by this team member, because that to me does satisfy the requirement. But you need to know where every image in the poster comes from. There must be an abstract that introduces the company and explains what they did. It has to be no more than 150 words. It should be very straightforward. We are this company. We built this RV to do this mission. Company information, photos of all team members. It can be a group photo or individual photos. Names of all members, job titles, roles, qualifications of each, such as their grade, career, goal, and major. Theme. So this is a section that goes into more detail about what the theme of the MATE competition is this year, and how that addresses ESG, environmental, social, governance goals, as well as UN sustainability goals. So it should be a somewhat quick discussion on the theme of the competition this year and why it's important. They need to appropriately cite the references and sources for this. So you would want to see some form of standardized reference format, MLA or something like that that says this information from this website, pulled up on this date, something like that. There should also be relevant photos, diagrams, or sketches talking about the theme. So you'd want a photo of a coral ridge or something like that if they talk about the coral ridge. Rationale should present, so design rationale should present, identify specific features of the ROV and outline the vehicle safety features. The company clearly explains the benefit of these design features, and the benefits of the design features should connect with real life tasks that the product demonstrations replicate. So something that I often find funny is that teams will make design rationale in paragraphs. This is a great opportunity to do arrows that point to images and bullet points that just say, it has the thrusters for movement. It has this for this, it has this for this. Design rationale, if you try and write it in paragraphs, can be very challenging to do it in less than a short novel. This doesn't have to be really detailed design rationale, just a quick understanding of this tool does this, this tool does this. And some teams do a better job than others at presenting that. Criteria, vocabulary and phrasing demonstrates the ability to communicate the engineering process and vehicle design to a wider audience. So again, if you are reading this and you happen to not come from an engineering background and you feel that you are struggling to understand what the team is saying, that means that this poster is failing. This is meant for a general audience. So this is the place to start taking them points away for that. Photos, diagrams, or sketches of the ROV's key design features. So does it have photos and diagrams of the ROVs and its specifically and of its tools? So if the ROV has grippers and it has does it have a special container that grabs things? Does it have tools to do this mission? And photos of those tools. That's what I would be looking for in terms of design features. Next is company evaluation. So they have to identify 3 employability skills from this list below: communication, creativity, entrepreneurship, autonomy, obstacles that they faced, intellectual development, critical thinking and problem solving, content knowledge, and teamwork. So they have to identify 3 of those and reflect and share how they have encountered these in their experience. That should not exceed 500. The entire evaluation should not exceed 500 words. Next is acknowledgement. So do they acknowledge the individuals, organizations, or companies that provided financial, logistical, and moral support? This doesn't need to be detailed. Just do they point out the people who supported them? And it does say in here that they also have to recognize mate as in their acknowledgments. Not entirely sure why they do that each year, but they do. Discretionary points. So did they go above and beyond with overall presentation, with mission statement, with photojournals or other pamphlets or other things that they've put in front of their poster, with spec sheet or safety manual that you thought was amazing, or community service? A lot of them will add a section on community service and mentorship or outreach. So that's where you can use discretionary points to recognize teams that have gone above and beyond in those ways. The Scout poster, the Scout marketing display rubric is very similar, so I'm not going to go through that one as well. But that should give you a good idea. When you're all done, make sure to, if you can collect those and actually probably put them in the judge's break room would be a good place to keep them as you're going throughout the day. When you're half done, if you can bring half of them to the room, we'll start entering them in as we get them. And I don't think I ever said this is per judge. So each judge will fill out their own sheet, and your numbers, the two judges that judge the same poster, you're allowed to discuss what you see. You're allowed to share your thoughts with each other, and debate a bit. But each judge comes up with their own scores. They don't have to match. So there's one sheet per judge per poster. All right. And with that, we're going to get into engineering evaluation. So for the engineering evaluation, teams need to be able to justify the decisions they made in their design. The key question is, why did they do the things that they did? You're not in this room, we're not judging whether or not they made the right decisions. This is about their ability to explain why they made the decisions. The presentation is 15 minutes long, followed by a 5 to 10 minute Q&A. We're expecting 3 judges per room. You'll be sitting in the room, and the students will be standing behind or next to their ROV on a table. When you arrive and check in, head straight to your assigned room after you check in. There should be signs taped on the door for each room saying, this is room 1. Go ahead and head on in and set up the room as you would like. It should already be set up a little bit. Feel free to move things around. You want to set it up so that the parents and family and friends, they are allowed to come in and watch the presentation, but you want them seated at your side. You do not want the parents behind you. There is a history of parents trying to flag their students down or try and give them hints or something. So you want the parents to your side, so the team is looking at you, not at the parents. Also they can take pictures. We ask that they not and they can record, but there is no option for a review after the fact. But they're welcome to record. They're welcome to take pictures. Once you're ready to take the first team, you'll go ahead and invite them in, ask them to place their ROV on the table that's in front of them. They must have their ROV with them if it is available. It's possible that they say, hey, our ROV kind of broke, and even though it's not working, we decided to just come and we didn't bring it. That I would still have rather that they brought their ROV, but they can continue to present even if they don't have it. But if it's on site, they really need to bring their ROV to their presentation. Once they finish setting everything up, and you can say, like, are you all set up? Have you put everything, have they put the ROV on the table and they kind of gotten themselves situated? If they say yes, say, okay, before you get started, we just like to introduce ourselves, and just give a short intro of your name and your background. So, say your name, this is your, what your current job is, or your most recent job if you're retired, and your background, so they know kind of who they're talking to and what sort of things maybe to focus on in the presentation. And say, you'll have 15 minutes to present. Do you have any questions for us? I'll note that at this point, the students are going to be super nervous, and so giving them a second to breathe and introduce yourselves also gives them just a chance to settle into the room a little bit. If they say that they're ready, if they don't have any questions, say, okay, go. I'm going to start your 15-minute timer now. You can start the timer on your phone, or if you want to bring a stopwatch or something like that, that's great. If you do use your phone, please silence any notifications. You just don't want that distraction throughout the day. Good teams will struggle to touch on all necessary topics in the allotted time. So 15 minutes goes by very fast. The presentation should feel very, very fast. It should be a rapid fire of all of these topics. Take notes very quickly. I recommend having a sheet of paper to take notes on, or take notes on sort of the back of the grade sheet. I don't recommend trying to fill in the grade sheet as you go because it all happens very quickly. Um, during the presentation, you can interrupt and ask a question or two, but we're not trying to create a pressure test environment. We're not trying to ask questions just to throw them off guard. I would think of it this way: if you were in a real business presentation and had a legitimate follow-up question, it's appropriate to ask. But we're not looking to ask questions. It's unusual. If I'm a presentation judge, it's unusual that I'm going to ask any question during a presentation at all throughout the day, but it happens occasionally. Most teams will go up for 10 minutes, have a good, okay 10 minutes, only answer about half of the things on the rubric, and then kind of fizzle out and forget what they were supposed to say. And that's okay. If they say that they're done after 10 minutes, just launch right into question and answer session. When the 15-minute timer does end, go ahead and stop it and make sure they hear it. I would let the timer, beep a couple times so they hear it. But then you can stop it. You can let them finish their sentence or their train of thought. Usually I'll let them go another 20 seconds or so. Or like if it's one student's about to finish their sentence and the next student's about to start their section, that's a good time to cut them off. But when the 15-minute timer goes, you don't have to cut it off right then. You can let them finish what they were saying. The questions during the Q&A should not be leading questions that help them get points. But if they say something that would have earned them points during the presentation, you can reward them points at your discretion. So this one is always a little complicated, but if you ask a question in Q&A you're not asking it because it would get them points, but you're asking because you're genuinely curious, and then they say something that would have given them points if they said it during presentation, maybe that's worth half points. So you can give them some points if things come up in Q&A. But it is not your job as the judge to get them points during Q&A. During Q&A, I do encourage you, usually the first few minutes of Q&A, you stay seated and ask a couple questions, and then usually at some point halfway through Q&A, I encourage you to actually stand up or go closer to the ROV to look at the details, ask questions, start pointing at it. Hey, why'd you do this? And how'd you make that? And why'd you do that? And my favorite question to ask at this point is, can you complete the whole mission? What can you not do? Because that exposes a lot. That really opens up, do they know the whole mission? Have they strategically chosen what to not do? Maybe they say, gosh, that task sounded really hard, so we focused on those three instead. It shows a team that really did think it through. The worst is a team that doesn't give you a lot of confidence and also says, yeah, I think we can do the whole mission. It's like, okay, you can, and you don't even know what it is. But it's a fun question. So can you complete the whole mission? How do you complete? If you can remember a couple parts of the fly through video that I showed earlier and say like, how do you pick up the coral, or how are you doing the coral ridge modeling for the Rangers? So if you can remember a couple mission tasks and to say like, how do you do that one? You can get some interesting conversations going. As soon as the team leaves, work on your grading sheet. So you have to do it fairly quickly before the next team comes in. If you wait to fill out the grade sheet, I promise you'll forget what that team said. All the teams start to blend together throughout the day in your head. If you need to, tell the team that's waiting outside, like, hey, we're just, please wait outside. We're just finishing up the score sheet. It's important to get the score sheet done before you forget what happened in the room. And you can also, as you're going through it, you're welcome to talk with your fellow judges. It's not that unusual to say, hey, do you remember them talking about teamwork at any point? And you can kind of say, oh yeah, they talked about that, this thing or that thing. So You can definitely confer with your fellow judges, but at the end of the day, the score that you put on your paper is your decision. So the score sheets between the judges do not need to match. Each judge submits their own score sheet for each presentation. Keep the score sheets at the end of throughout the day, and volunteers will come by to pick them up as the presentations are going on. Okay, so I'm going to go through the score sheet. I'm only going to go through the Ranger one. The Scout one is quite similar, so there shouldn't be any big surprises there. The first is safety. The presentation highlighted safety features and philosophy. I should mention first, all of these are 0 through 4. So there's a rubric that is actually here. Yeah. So the scoring rubric is 4 is exceeds requirements, 3 is meets requirements, 2 partially meets requirements, 1 needs work, 0 missing. A very good team should be mostly 3s. It is meets requirement. Exceeds requirement is legitimate. Like, this does everything the score sheet says you should do, and also beyond what I would have expected. So it's a good team should be mostly 3s. All right, so content presentation highlighted safety features and philosophies. Did they actually touch on safety features and philosophy? Safety measures, vehicle specific safety precautions related to the task and missions, mission tasks. So do they point out the thruster guards and the there's a lot of pipe cleaners this year. Are they sure that their equipment won't get caught in pipe cleaners, and have they been aware of that? Do they have correct signage on high risk safety pieces? Do they have fuses in the correct place? Do they make sure that their tether is properly transported on a reel and doesn't get damaged? So do they talk about safety precautions? Also described how well the team's safety philosophy covers personnel, equipment, and operational safety. So do they have a philosophy? Do they have a plan? They talk about like do they wear safety glasses whenever they're in their workshop? Do they for operational safety? Do they wear what do they bring with them whenever they're poolside to make sure that they themselves are being safe? And team presentation. All team members contributed to the presentation in Q&A, making sure that the presentation wasn't dominated by 1 or 2 team members. And this is both presentation and Q&A. Something you can do if you see a team that's really being dominated by 1 or 2 team members, is to single out and say, can you tell me what is this? You can single out a team member during Q&A and push them to answer if you haven't heard them at all through the presentation. But for this one, it is a somewhat balanced presentation. Company was well prepared for the presentation. I don't want them reading off of flashcards. They should be better than that, but you can be even worse. At least they made the flashcards. You'll get teams that this is the first time even trying to go through it at all, and it shows very obviously. Delivery presentation was dynamic, clear, and informative. Teamwork demonstrated project was collaborative effort. So you want to make sure that the ROV was actually built by a combination of all the team members, not like just one member who's actually built it all. Company seemed cohesive, inclusive, and supportive. This doesn't necessarily mean that they don't argue. I love teams that are super passionate and obviously, kind of maybe argumentative is the wrong word, but passionate when talking with each other. But you can quickly tell the teams that are actually a team, and actually and have become friends and support each other and are inclusive and do they let each other answer questions? Do they actually support each other? Do they yes and during Q&A? Do they say, when someone answers a question, they're like, yeah, and also this, so are they actually supporting each other? Company demonstrated self-teaching and mentorship. Did they learn something through all of this? Do they acknowledge donor funds, materials, and equipment? Lessons learned. Do they have significant technical lessons learned? And then do they have significant interpersonal lessons learned? They should talk about both. Content, or getting into theme and tasks. Does the presentation talk about the real world mission? So they should talk about coral ridge and ice, glaciers running into oil rigs, and all are using wind farms to power oil rigs. So like all these things that are in the actual mission tasks, relating that to talking about the real world. They should also demonstrate an understanding of how their ROV systems were appropriate to perform the mission tasks. So they should, as they're talking about, we chose this thruster, we chose this design because we knew in the mission we were going to do X, Y, Z. So they should relate it back to the actual mission, not just design a generic ROV. It should be specific for this purpose. Overall design and workmanship is the company's own, well conceived and executed. The design and workmanship is robust and shows skillful execution. For these, you're getting into like, is everything tidy? Is it well, especially if there's any wiring? Does the vehicle look like you could drop at a short distance and it would survive? Does it look well put together? Design is modular and serviceable. If you had to take off a motor or a tool and swap it out with another one, could you? Was there any thought put to that? Or at least do they talk about it? Demonstrated thought to marketability and usability by others. One of my favorites for this is, do they show you the controls and say, this is up, this is forward? Do they talk about you, the customer, using it at all? Discuss the extent to which the vehicle was tested prior to the event. Again, you're not scoring whether or not you agree with their testing plan, but do they at least talk about it? Engineering design rationale, described an overview of the vehicle as an overall system and its subsystems. This one's honestly one of the harder ones to score every year. But do they talk about the design of the vehicle holistically? And so like one of my favorite examples is when you have a team that says, we knew we had to lift something really heavy, so we had to design the entire vehicle around that task. So we knew we needed some sort of mount in the middle to lift something. And so we kind of grew the thrusters had to be further out. So like, as they're talking about the tasks, did that shape the overall vehicle to meet those tasks, as opposed to they just strapped on some tools on all the different sides? Next is designing, engineering reasoning behind vehicle systems and components. So this is individual pieces engineered to solve the engineering reason behind individual components. Data used to compare and select among alternatives. So this frame material was this much heavier than that frame material. This thruster was this much more powerful than that thruster. So do they actually show numbers that say this is why we made this decision? Build versus buy. Again, we're not punishing them for the decision. They need to explain the decision. So how much of the components did they build? How much of them did they buy? And then same for new and reuse. So they just need to say, we reused the thruster because it was perfectly fine and it would save us money and there's no reason to get a new one. That's a justification. They just need to address it. Next is discretionary points. So is there exceptional design and innovation demonstrated? Did they develop exceptional original software? Did they demonstrated remarkable effort to design and manufacture every piece of the vehicle? So if you come in with a team member comes in and says, we made every single electrical board and these thrusters are home assembled, and we made the camera enclosures, and so is a lot more of it homemade than you would expect. And then you have an opportunity for discretionary on other deductions. Coaches or mentors are overly involved or interfered during the presentation or the build process. If the coaches are interfering during the presentation, I encourage you to give one warning. If they continue to speak up, coaches or parents or whoever, if they continue to speak during the presentation, I strongly encourage you to kick them out. This is the students' time, and if the coaches aren't going to respect that, then they need to leave the room. Significant overuse of commercial components without adequate justification, and then significant overuse of reused components without adequate justification. And again, it's very easy to justify. They just need to say, like for reused components, for example, they just need to say, we reuse the same motor because we tested it, it's working fine, and it would be really expensive to do something new, and we don't see a reason to get anything more powerful. Like, that's a perfectly fine justification. All right, so you'll circle all those. You don't need to add them up. I'll add them up as well. There's also some weighting, so like if you just add up what's circled, it won't quite come to 100. There's some weighting involved, but that's the whole rubric. So thank you very much for joining me if you're all the way here at the end, and I look forward to seeing you all on April 18th. Bye-bye.